3, 2, 1. Hi, my name is Liv, and today we're going to be making an abacus. Now, if you have no idea what that is, don't panic. We're about to fix that. So let's get started. An abacus is some seriously ancient tech used for the world's very first calculations. A misconception that this is solely an ancient Chinese device is untrue, as we see evidence of counting boards like this as ancient as the Babylonian Salamis tablet from around 300 BC, aka hella old. Precursors to the more well-known abacus style I'm modeling today can be seen in ancient Greece and Rome, made out of marble and bronze. They used pebbles instead of beads, which is why the Latin word for pebble is calculus. During the 11th century is where we see the Chinese abacus made of beads and rods that we all know and love. This is called the swanpin, meaning calculating plate. Today I'm creating the Japanese version called a soroban, which differs only by having one bead above the reckoning bar instead of two. I've been wanting to make one of these guys for such a long time because I love the idea of creating this ancient and awesome tech with the brand new tech we have today of modeling and 3D printing. Okay, so we have an abacus. Well, now what? Well, let's learn how to use it. The beads above the beam are called heaven beads, worth 5 each. The beads below are called earth beads, and they're each worth 1. To set the numbers on your counting device, use your thumb to move beads up, and then you can use your pointer finger to move them back down. To fully clear to 0, you can move all the earth beads down and the heaven beads away from the reckoning beam, and this is what is called a clear frame. Working from left to right, we can actually count from 1 to 9. So 5 there, 6, 7, 8, and 5 plus 4 equals 9. Let's try some addition. So we can make a hundreds place here, set that to 2, a 3, and how about 5 plus 2 is going to give us 7. So right now we have 237. So let's do another number here. This is our hundredths place. So 1, 5, and how about a 2? So that's going to be 152. So let's add those together. In our hundredths place, we have a 2 and a 1, which is going to give us 3, so 300. In the tens place, we have a 3 and a 5. So we'll add those 3 beads and that 5 bead to get an 8. And then our last column, our ones column, 5 and a 4, so we get 389. Alright, but how about subtraction? So let's start with 4 and how about a 3, so we have 43, and minus 12. 10 and a 2. So here we've got 4 minus 1, so we know that's just going to be 3 beads, and then 3 beads minus 2. 1 bead, which is going to give us 31. Not too bad. But how about some much bigger numbers? Let's try 187 and 125. Because in our hundreds place we just have that 1 bead represented, we know we're going to have 0 in our hundreds column. So in our tens, we've got an 8 and a 2, and that 5 bead, the heaven bead, isn't on our other column, so we know that the heaven bead's going to stay here. And then we'll just have that 1 blue bead, which gives us 6. Then here, our heaven bead is being subtracted, so we're just going to have those 2 beads, which is going to give us a result of 62. So 6 and a 2. Ta-da! Not too bad. It's really important that with all the resources we have today, we continue to learn from our ancestors and how they made computer science and all of our mathematical techniques possible. Thank you for joining me today on my Abacus journey. I wish you the best of luck with yours.